Lesson: Addressing privacy in algorithmic decision-making. Addressing privacy in algorithmic decision-making is a critical component of modern information privacy management. As algorithms increasingly influence decisions in sectors such as finance, healthcare, and law enforcement, the potential for privacy violations and biased outcomes grows. Therefore, it is essential for certified information privacy managers to understand and mitigate these risks through actionable insights, practical tools, and robust frameworks. The first step in addressing privacy in algorithmic decision-making is recognizing the various ways in which algorithms can impact privacy. Algorithms can inadvertently collect, store, and process vast amounts of personal data, often beyond the scope initially intended. This can lead to privacy breaches if the data is inadequately protected or if unauthorized access occurs. Moreover, algorithms can perpetuate or even exacerbate biases present in training data, leading to unfair or discriminatory outcomes. Such biases might infringe on privacy by disproportionately affecting certain demographic groups, as demonstrated in studies where facial recognition algorithms exhibited higher error rates for individuals with darker skin tones. To address these issues, professionals can employ several practical tools and frameworks. One such framework is the privacy by design approach, which integrates privacy considerations into the design and operation of technological systems from the outset. PBD encompasses principles such as proactive rather than reactive measures, privacy as the default setting, and full lifecycle protection of data. By embedding these principles, organizations can ensure that privacy is a fundamental component of algorithmic processes. Another vital tool is the implementation of differential privacy, a technique used to enhance privacy in data analysis. Differential privacy ensures that the removal or addition of a single data point does not significantly affect the overall outcome of an analysis, thereby protecting individual data points from being identified. This technique can be particularly effective in large datasets where the risk of re-identification is high. For instance, differential privacy has been successfully employed by companies like Apple and Google to collect user data for product improvement while safeguarding individual privacy. Data minimization is another practical strategy that can be utilized. By limiting the collection of data to what is strictly necessary for the intended purpose, organizations can reduce the risk of privacy breaches. This principle is enshrined in regulations such as the General Data Protection Regulation in the European Union, which mandates that data collection should be adequate, relevant, and limited to what is necessary in relation to the purposes for which they are processed. In addition to these tools and frameworks, professionals must also focus on transparent algorithmic processes. Transparency involves making the workings of algorithms understandable to stakeholders, including the individuals whose data is being processed. This can be achieved through algorithmic audits, which assess the fairness, accuracy, and privacy implications of algorithmic systems. For example, an audit might reveal that an algorithm used in hiring processes disproportionately disqualifies candidates from minority backgrounds, allowing the organization to rectify these biases. Case studies provide practical insights into the challenges and solutions associated with algorithmic decision-making. One notable example is the controversy surrounding the COMPAS algorithm used in the U.S. criminal justice system to predict recidivism. Studies revealed that the algorithm was biased against African American defendants, who were more likely to be incorrectly classified as high risk compared to their white counterparts. This case underscores the importance of rigorous testing and validation of algorithms to ensure they do not reinforce existing biases or violate privacy rights. Risk assessments are another crucial component of addressing privacy in algorithmic decision-making. Conducting regular data protection impact assessments allows organizations to evaluate the potential impact of their algorithms on privacy and identify measures to mitigate identified risks. DPIAs are not only a best practice, but also a legal requirement under the GDPR for processing activities that are likely to result in a high risk to the rights and freedoms of individuals. Education and training are essential to ensure that all stakeholders involved in algorithmic decision-making are aware of privacy risks and mitigation strategies. This includes training data scientists, engineers, and decision-makers on ethical considerations and privacy-preserving techniques. By fostering a culture of privacy awareness, organizations can better navigate the complexities of algorithmic decision-making. Moreover, collaboration between privacy professionals, technologists, and policymakers is vital to developing comprehensive solutions to privacy challenges. Policymakers play a crucial role in establishing clear guidelines and regulations that protect individuals' privacy while allowing for innovation in algorithmic technologies. For instance, the GDPR provides a robust regulatory framework that balances privacy rights with technological advancement, serving as a model for other jurisdictions. Finally, engaging with affected communities and stakeholders is critical to understanding the real-world impact of algorithmic decisions. By involving diverse perspectives in the design and evaluation of algorithms, organizations can ensure that their systems are equitable and respectful of privacy. This participatory approach not only enhances the credibility of algorithmic systems, but also builds trust with the public. In conclusion, addressing privacy in algorithmic decision-making requires a multifaceted approach that encompasses privacy by design, differential privacy, data minimization, transparency, risk assessments, education, and stakeholder engagement. By implementing these strategies, certified information privacy managers can mitigate privacy risks and promote fair and equitable outcomes in algorithmic processes. As algorithms continue to shape the modern landscape, it is imperative for privacy professionals to remain vigilant and proactive in safeguarding individual privacy rights.